Okay, today we are going to talk about differentiability and continuity. So we got this big word here, differentiability, and all that's saying is, hey, can I find the derivative at this point? All right, and just the process of identifying whether we can take the derivative or not, we are identifying whether it is called differentiable, and so that's where this word is coming from. Okay, the other thing we're going to look at is not just the derivatives at a point, but also the continuity of the functions and how these two relate to each other. So before we get too far ahead of ourselves, we want to just take a look at our definition of a derivative, and it is just a limit equation of the slope formula. And with limits, we know the left-hand limit has to exist, the right-hand limit has to exist, and they have to equal each other. And if that happens, then it is differentiable, is what we say. So all differentiable means is that we are able to take the derivative at that value for c. All right, so looking at this first function here, we have our greatest integer function. So if we just draw a sketch over here, we'll have a better idea of the continuity at first. So when we have this, we can see that this definitely is not a continuous function because we have these jump discontinuities at all of our integers. So at 1, 2, 3, we're jumping there. Okay, and because of that, this is not a continuous function. All right, specifically for this, we're going to take a look at the derivative at this point 0. Okay, now the function exists at 0. We have 0, 0. But for the derivative, if we take a look at that, we have f prime of x, and we're just going to take a look for the derivative as the limit as x approaches 0. All right, and if this is a case, kind of using this function up here, it is going to end up being the integer function x over, as we're approaching 0, x minus 0 is just x. Okay, so we just plugged in f of x minus f of 0 over x minus 0. So that's what we did here, and that's where this derivative is coming from. And now what we're going to do, again, we're using this limit approach. We can't do a direct substitution, so we're going to take a look at what this greatest integer divided by x is. All right, now it's going to help to take a look on the calculator about what's going on. So I already plugged this function in, and if you go to graph and you zoom in a little bit, this is what our graph actually looks like. So it's kind of a weird looking graph. We're going to go ahead and put this with our greatest integer graph just so you can see the two at the same time. But what's happening is we kind of have these curves going up, and this isn't exact by any means, but it just kind of gives you an idea for what's going on here. And then we have this going up here, and then right here, those are all equal, and then, or it's 0, I should say, 0 divided by some number. And then this part is coming up. And here, let's say, just so you guys get a better idea, this is our function here, but if we graph just the regular integer function of x, this is our original function, so you can see the steps. Okay, so it's kind of got a weird look to it. It goes like this, and then here it looks like it's kind of coming down. So this is what our graph looks like, real goofy looking. Okay, now we want to take a look at what is happening at 0. So from the left hand side, okay, as we look at our graph, this, as you can see, starts increasing without bounds. So to symbolize that, we're going to go ahead and put infinity. From the right hand side, though, you'll notice it's always 0, so it looks like it's going to be 0. As a result, what happens is the left hand limit and the right hand limit are not the same, and therefore the derivative does not exist at 0. Okay, so it turns out, in general, if you have a function that's not continuous at some value, okay, so in this case we took a look at 0, it's not continuous here, it turns out it's not always differentiable there. Okay, but here's the thing, you guys. If you know a function's not continuous, right, we definitely know it's not differentiable. But if it's differentiable, all right, does that always mean that it's continuous? Okay, or if it's continuous, does that always mean it's differentiable? So let's take a look at this next example here. Example 6. We have the absolute value of x minus 2. So that's a shift right 2. The absolute value. All right. So this is our graph, and we want to look at the derivative. Okay, now again, if I'm doing the derivative of f of x, I'm going to go ahead and do the limit as x approaches 0. Okay, so I'm going to use this formula. My first one, I'm going to have f of x, and then I'm going to have minus f of 0. Well, if that's the case, then when I take the derivative, it turns out I get the absolute value of x minus 2, and then we're going to have that over just x minus 2. Okay, so we want to take a look at this graph. Now, this graph, you should know this by now. We've seen it a couple times yet. And all this is we have an open circle right here, and then we're going to the right. And then we have an open circle down here, and then we're going to the left. All right, and this is what we have for our derivative. Now once you have that, we're going to take a look. Okay, so this is our f of x minus f of 2 over x minus 2, because we're looking at the derivative. Oh, you know what? Yeah, this is where it's wrong. This should be as x approaches 2 here. Okay, so we're looking at our derivative as x approaches 2. Now when we're coming from the left, we see that it equals -1. When we're coming in from the right, we see that that limit is actually going to be at 1. Well, that's a problem. We have this continuous function, but the left-hand limit and the right-hand limit aren't the same. So as a result, even though this is a continuous function, all right, that doesn't imply that it's going to be differentiable at every point. So it turns out anytime that you have a graph with a sharp turn, it's not going to be differentiable at that point. Okay, and the reason why is because when you have that occur and you try to take the limit from both directions, you get different limit values.